So next topic is my very, very important topic is boiler tube leakages. How this AI ML is being used to find out boiler tube leakages. And how, if let us suppose your plant is there and you want to install this system, what are the things that is being required to install this boiler tube leakage detection system? So yes, in the STIAG also we are having different modules. Basically, whatever I have shown you, of course, many companies is having, they also claim that they are having the digital twin, they are having the AI ML model, they are having the predictive analysis and all, but our product that is very much mature, we are having a continuous development for the last 20 years in Swingenberg and Essen in Germany. And yes, in India also, we are having very big support from Germany. So definitely it helps us a lot in doing the project. So this is basically how this AI ML is going to help us to detect the tube leakages. So as you know, tube leakages is basically one of the main problem in all of the power plant. And uh, what are the things that will be required that I will show you. So you can see this is my boiler. This is generally a boiler of German power plant, but of course we are having a two-pass boiler in Indian power plant. This is basically a tower type boiler. So, but the concept is same. The thing is that we require the acoustic signals. We require the DCS system. We require the OPC interface, and we require the acoustic signals for our which is generally installed by the manufacturer, so that from the sound waves you are able to take the decision that whether you are having the leakages and all. But uh, it is completely on your experience. Sometimes you are able to find out, yes, there is a leakage, but it's basically human. And one thing is from the technology, from the AI ML technology, that yes, whether it will give you a correct answer that yes, whether there is a leakage or not. Of course, from the acoustic side, I have seen that many of the operator, they go to the boiler at different level, and with the sound, with the help of the sound, they try to analyze that yes, there is a leakage or not. So one thing is that you require the acoustic signals. This is the data that yes, almost every power plant is having 2 to 10 tube leakage per unit per year. At least 2 tube leakage is always you must have in, and it goes to 10 or 12 also. Depends upon the condition of the boiler, depend upon the coal and ash and the way you operate the boiler. And there is a tube failure. So definitely when you are having a major failure, you are having a very, very high availability loss. And the main reason of the tube leakages are, of course, overheating, defective welds, erosion, internal corrosions. Not in Germany, in India also, everywhere there is the same problem: overheating, defective welds, erosion, and internal corrosion. So, what is the principle behind it and how it works? Yes. So, well, first thing I told you that we require the acoustic signals. So, of course, there are many companies which gives the acoustic signals. For this for this module. So 50 to 30, we require 15 to 30 this acoustic. But if it will be 30, that is very good. Then, of course, we require cables and require a hardware, a server. So here you can see that if you don't have the acoustic signal, you will have to install these acoustic signals. And these are the places where you have to install. If it is already installed, there is no problem. So the location of the microphones will be like this. Full boiler we shall have to cover, especially the first pass area and all. In the right side, you can see it's like a two pass boiler. So these are the points where we shall have to locate the sensor. So these are the area where we shall have to locate the sensors. So acoustic signals is must. So what is the problem with the acoustic signal? Acoustic signal produces false alarm. But how to catch those false alarm? That is a challenge. And yes, every alarm requires a time consuming check by the experts. If expert will go, he will check the sound. Based on his experience, he will tell. And detection of leakage is delayed. Then if you will be able to, if the leakage detection will be delayed, then you are having a major damage. So this is the one of the thing. So we are having a AI ML based solution for this predictive analysis of the tube leakage. So what we'll do, we shall take those acoustic signals into a system. Let us suppose 30 sensor is there and some more sensor we shall take like we shall take the megawatt, we shall take the pressure temperature of the boiler, we shall take the feed water temperature of the economizer and almost 50 signals we generally we take for this module. And this we shall collect. Of course, we require the DCS, we require the OPC interface. That is prerequisite for this type of module if we want to install. And then we shall collect those data. We shall collect those noise level decibel dB signals into our system. And right now, it will be same like my statistical process control or early detection of the fault, which I have told you in my earlier module demonstration, that we shall collect the actual acoustic signals. So of course you can see this is my actual acoustic signals. Here I cannot catch that where is my tube leakage. No, it's not possible. So what I will do, I will use my digital twin. I will use my neural model and I will create my reference value. So this dark blue is my reference and this light is my actual. And then I will develop my KPI. And once my KPI is developed, then I will be able to predict my fault. That yes, this is the area of my fault. Here I am having the fault. Here my tube leakage has been started. So of course, whenever we shall install, we require the signal. Some of the power plant they don't have the signals, so we install those signals, and then we install our hardware and all, and then we collect the data, we develop the neural model, and then we normalize the data, and then accordingly we try to catch where there is a fault. So the full trend you can see from left to right. You can see my sensor data. So of course, sensor data, that is the acoustic data. That is very, very important. That is the main thing from where we shall be able to we shall be able to find out the fault. And then learning process. AI technology means neural model. Of course, we shall have to develop a very good neural model for that. Then we shall have the reference and the actual. Then we shall have the KPI. And then we can have the action. That yes, from here, this point, that right now there is some abnormalities and we can catch those area that yes, from this signal area, I am having the fault. So from that area, we shall catch and we shall try to find out the fault and the leakage edge. Uh, you can see my screen, no?
Yes, yes.
Okay.
Yes, sir.
But there is some noise actually. Okay, right now it's okay. So if you have any questions, sir, you put on the chat box so that we can discuss after this presentation. Then I will go to my last one, that is coal matrix solution. Okay. So yeah. I can see some question is there. Okay, I will answer after this one. If you have any more question, you can put. Yeah. So generally in a power plant, generally how you find out that there is a leakage or not leakage. So yeah, one thing is of course the acoustic method. From your experience, you try to find out that yes, whether there is a leakage or there is not leakage from your own experience, from the acoustic sounds. Second thing is you do the balancing. You are having the feed water flow and you are having the steam flow. So if there is a major differences, you understand there is a leakage in the system. And third is of course, we are having the predictive analysis method. We tell it as ALMA is our product. So here there is a case study. 20 August 2000, of course, time is past. So here you can see that here on 28th August, the noise level was within the limit. No, 28th August, we got the alarm. Feed water balancing, there was a alarm. Predictive analysis also, there was a alarm on 20th August. Feed water balancing means there was a difference. Noise level was also above the limit. So noise level also given the alarm and so all the three were given the alarm 28th August. So feed water balancing, it has given two alarm. One was false, second was two alarm, first was false. But here we can see that 10th August, noise level was below the limit. Feed water balancing was also okay. But this in a predictive analysis, ALMA model, they have given the alarm based on the neural model AI technology and all. But here you can see that 10th August, there was alarm. Here also, we can see that feed water balancing, there was no alarm, but predictive was also alarm. Sorry. So here we can see that yes, there was a tube leakage, but noise level didn't able to predict because noise level was below the limit. Because when you are having very, very small tube leakage, then it's very difficult for the noise level also to predict the fault. Feed water balancing also comes because of the instrumentation and all, it comes okay. Then the only technology which can help us is our predictive analysis and all, which just a minute, just one. So we can see that in this case where our noise level were also below the limit, the feed water balancing was okay, but the predictive analysis found the fault because the leakage was very small. But of course, we can catch the fault with the respect to the difference in the when there will be it will become very big fault, and when the leakage will increase to the maximum one. So here we can see that with the help of AI model and all, we got the fault well before the fault occurred. So there are some, of course, what we got from this, the, there are some studies and all where we got alarm and all, and where really we found that yes, where there the difference was not too much between the feed water and the mainstream and the alarm, but with the help of this module, we able to find out yes, there was a damage. So the advantage is that there is no false alarm, early detection of the leakage. Then the damage will be less. And then it helps us to have to make our decision based on some technology. You can take the decision. One thing is that you are taking the decision manually based on your experience. One thing is from some technology you are taking some decision. And you will get the notification not going to the boiler and all, you will get the notification on your email or your mobile phone that yes, this is the area where the limit has crossed, where the AI ML model is showing that yes, there is some fault, there is a chances of tube leakages. So I hope that this how this technology is working to detect the boiler tube leakages. I hope that, of course, not in detail, but up to some extent, you must be able to know right now. If you have any question, you can ask. Then otherwise, I will go to my last module, that is course selection matrix. Which matrix is used in your model precision F1 scores? What is the allowable volume matrix generally? I didn't able to get your question. What is this metric? We are using this model, and based on the data and all, we train and we develop the KPIs. And of course, the accuracy that is basically less than means for the accuracy is very, very high. And I can say that the precision this is very, very high. And we are having a error that is less than 1%. Which incurs the major cost in case we install predictive analysis for volatile leakage. It's a whole package, sir. Of course, it's a whole package that but these are the prerequisite because generally you are having the DCS, you are having the OPC. So you require this acoustic signals and so of course we provide it in a package. Yes, if it will help you, what is the major parameter that help AI to detect? The major parameter that is basically, of course, the acoustic signals, because and some of the main parameters that I told you that we take the mainstream pressure, we take the mainstream temperature, pressure, temperature, around 50 parameters we model, and accordingly we model and we train the data, and accordingly we try to find out that whether there is a leakage or not. Of course, the 50 to 60 data we train. Durga Balaji P, you can discuss with me on my mobile phone, maybe, sir. I because Are you sure I will share my contact and mobile number? CPP, which rule? What is the allowable layer? Deviation of data validation in epsilon. There is no any such type of allowable deviation, I can say. But of course, we see that the deviation that is less than 1%. We are having a accuracy of almost where we're 99.2%. So we are having a deviation of maximum 0.8% we have observed. And even we are having the coal, we use this AI/ML technology for calculating the GCB of the coal, online GCB of the coal also, where also we have found out that yes, our deviation was less than 3%. Even where I can say that calculating the online GCB of the code with the help of digital twin and AI model is not an easy thing. But also in NTPC Dadri also we tested the things and our deviation was less than 3%, which was very good, I think, for the coal GCB also. Kindly, sir, CCPB detail where AI tools have been implemented. Sir, basically, we have used this AI tool. Of course, for CCPP, we have not implemented any online, but for offline study, we have done for some like Indian glycol, then HMEL, our plants and all. There we have done some study and some of the study that is going on for our own CPP plant. But yes, you can contact me. We can have some detailed discussion on this one. How you handle outlier. Sir, data validation and how we handle outlier. Outlier, basically one thing is that it's a range check. First thing is range check. So if I am a data which is just out of the range, which we know that is out of the range, that is basically first layer of check. Then second layer of check is of course with the help of this digital twin and then data validation where we are very close and the result is very good, very fantastic result. So yes, I able to explain you how this AI ML technology we are using for for my data validation, for my boiler cleaning management, for my predictive analysis of the fault. Then I can say this boiler tube leakages. And one of the thing is that right now we are using this AI ML technology for our coal selection matrix.
Sir, can I ask a question? Hello, am I audible, sir?
Yeah, please, sir, please.
Sir, actually, that outlier question, actually, see, initially when you are taking the data and when you are validating it, then you can handle the outlier. But after the model is, you have implemented the model and it is running in the system, then you also do the updation of data, running data, real-time data, right? So then
Okay.
how do you handle the outlier and what is the frequency? How do you handle that data before giving that data to the model, updating the database to the model? You understood my question, sir?
See, sir, actually, we are having a continuous training of the data, continuous training.
Correct. So naya data may be outlier रह सकता है ना sir? In even the real time data also there are outliers.
आउटलेयर तो सर हमेशा हमें देना पड़ेगा ना एक कि भाई इस डेटा के आउटलेयर पे जो भी यदि मतलब आपको आएगा तो उसे हमें हटाना है.
How do you do that? You do it manually or how do you do
वो
that?
तो स्टार्टिंग में हम लोग सर मैनुअली देते हैं.
Initially, but after
that
continuous,
it after training and all it takes continuously from itself.
तो उस ट्रेनिंग में जो डेटा आ रहा है उसमें आउटलायर्स रहेगा ना? हाउ डू यू हैंडल दैट? दैट इज द क्वेश्चन.
मैंने अभी तक तो इस टाइप से कोई आया नहीं है सर चैलेंज हमें.
सर जब हिस्ट्री में आउटलेयर्स रह सकता है, अभी रियल टाइम में क्यों
नहीं नहीं,
आउटलेयर्स?
मैं बता रहा हूं सर, यदि इस एक बार हमने उसको ट्रेन किया, जैसे आप मान लीजिए 540 रखते हैं, ठीक है, मान लीजिए आपका
राइट,
540 डिग्री सेंटीग्रेड है, ठीक है,
करेक्ट।
हमने रख लिया आउटलियर इसको 500 डिग्री सेंटीग्रेड रख लिया मिनिमम, एंड 560 रख लिया मैक्सिमम।
Above
ये
that
मेरा,
or the,
मान लीजिए
yeah,
520 हमने रख लिया
based on the
minimum.
load it will be varying, so
And
that
no. Let us suppose if it is based on the manufacturer data and all, starting में हमें डालना पड़ता है. अब let us suppose vacuum है, तो उस हिसाब से generally we do not train the vacuum, but if it is a process data like main stream temperature, main stream pressure और extraction side, तब तो outlier हमें define करना पड़ता है पहले, सबसे पहले. Once we have defined the outlier, and if the data is coming or means यदि आउटलेयर को वो मीन्स उसमें आ रहा है, तो इट इज रिजेक्टेड इन द फर्स्ट वे, मीन्स फर्स्ट स्टेप. उसके
right,
बाद
right.
जो भी डेटा है उसकी जो हमारी होती है ट्रेनिंग, और
वो
उसके
filter होता है।
अकॉर्डिंगली काम होता है. उसको नहीं ट्रेन करेंगे, जो आउटलेयर में के अंदर
Got
जो
it,
आएगा
got it,
उसी को
got
ट्रेनिंग
it,
होगी.
got it, got it. So through the program you are defining a range, and
या
you are there itself. So every data, training data, even the real time data when it is getting updated in the data training, so before
करेक्ट.
that it will get filtered there.
या
Yeah,
जो
sir.
गुड
Even
डेटा
my
होंगे उसी की ट्रेनिंग होगी, ऐसा नहीं है कि बैड डेटा की ट्रेनिंग हो जाएगी.
Praveen ji, your previous
In
thing
training
on,
also and in real time also, the outlier detection will work.
राइट.
In
yes,
real
sir,
time
Praveen ji,
also it will.
one more question, Mr. Praveen.
हाँ सर, हाँ, काइंडली.
Yeah, this is regarding the smart blowing, soot blowing,
हाँ हाँ.
where you have used various factors, right? Normally, we use the temperature before soot blowing and after soot blowing for comparison. But you have used a lot of components like calculating the heat value and all that.
हम्म.
So this particular, it is why you have chosen boiler efficiency and all those. They will come how they are directly related to the soot blowing.
Sir, one thing is that in a power plant, one thing is that you do the soot blowing either on the based on the time given by the manufacturer, or you see the backend temperature, my backend temperature is increasing or my metal temperature is increasing, you go for the soot blowing.
Okay.
But there is a technology, because one thing is that let us suppose my surface is not dirty. Let us suppose right now my boiler is running in a good way and my boiler is not dirty. But since your manufacturer has given you instruction to do the soot blowing for every 8 hours, you are doing the soot blowing. But it is you will be able to know that whether my surface is dirty or not dirty. So there is a technology. From the digital twin, I will be able to tell you that whether my surface is dirty or not dirty. I will use my digital twin. I am having you. I will take your plant geometrical data. I will take the process data of the plant, and from the by simulation of the digital twin, I will be able to tell you that yes, your surface heat transfer coefficient is deteriorated, and right now the surface is dirty. So you require the soot blowing. So soot blowing, one of the criteria is also dirtiness. Second thing is time, then reheater metal temperature, so many things, sprays and all that, and of course cost and all. So of course I can say that a fuzzy logic is being used for this one, and which is very successful, and we shall be able to really guide you that when to do the soot blowing. क्योंकि
Okay, thank you.
आपको आपके सरफेस की डर्टीनेस पता होनी चाहिए. आपने यदि बिना सरफेस के डर्टीनेस से आप एवरी शिफ्ट कर रहे हैं बेस्ड ऑन योर एक्सपीरियंस एंड ऑल, उसको आप बढ़ा सकते हैं. आपने लेटर सपोज 8 घंटे की जगह 16 घंटे में किया, तो कुछ तो आपका स्टीम बचा, एंड दैट इज अ वेरी कॉस्टली स्टीम. So definitely you will be able to improve your efficiency and heat rate of your power plant.
Right, sir. Sir, the other question, one like metric I was, no? The metric, see, how do you evaluate the model? See, the metric can be F1 score, precision, accuracy, recall. There are many metrics. So how do you choose which metric to use, and what is the generally acceptable, value of that metric? Whether recall is used or false positives. How do you evaluate the model before you implement it?
See, sir,
General question.
actually, Actually, we are having experts who works because in the neural model is not only that everybody knows and everybody do. So we are having a team of expert who do the modeling and according to of course with the respect to the results they discuss the thing and accordingly we take some of the but you are telling about the matrix and all that definitely some of is our USP and in this platform is difficult for me to explain.
Thank you.
Sir, one more question
But
apart from this.
Mhm.
Is there any technology, sir, that underground water line leak detection analysis by using AIML, that whether it is pipeline is healthy or dirty, to identify the leakages like that problems?
Sir,
Are you clear, my sir?
as I told you, sir, that acoustic signals. So training of the acoustic signals is basically being used, and then KPI is being generated, and then
No,
accordingly
not sir. It is not boiler. It is underground pipeline, CW line and
underground pipeline.
CW line and all.
So for CWN line and all, if leakage regarding leakage, sir, once more you tell the question.
Underground water line, sir.
Okay.
The healthiness of the pipeline, whether it is inside erosion, corrosion, and what is the leakage performance, and that to identify that problems, is there any technology like boiler tube is identifying, na, sir, that like that?
Understood. Understood. Uh, till now we have not done, but of course we can do if we shall discuss the things and all. And what are the means? What are the things that is basically involved in the leakage? So we shall, if we shall be able to take, and if we shall be able to get some data, then definitely we can come to some conclusion. It's not, I can say, not possible, but we shall have to understand the problem and the data which is associated with those problems. So what are the data that can be possible to get, and then in which form so that we can train and then we can get, sir.
Thank you, sir. Thank you. Thank you.
Okay, so I will take just 10 minutes to explain you one more module that is not in the plant, that is outside the plant, that is cool selection matrix. So this is also one of the new technology that is being used. That is coal selection matrix. That is this technology is basically used in most of the Europe, but we are trying to implement this technology in one of the Indian power plant, that is Mahagenco. So of course here everything we shall take into account that from which source we are going to take. We are doing the logistic planning. And then what about we shall take stockyard planning, train scheduling, bunker. Then we shall have the DCS interface and all. So the thing is that the main aim is that if let us suppose this is the peak time, 6 p.m. in the evening, and you require a good coal so that you have to reach your peak demand. So this coal selection matrix will tell you that right now in the bunker, what is the GCB of the coal you are having? Or let us suppose by in the coal yard also, if you want to take the coal, so what should be the mixing of the coals and all, so that you will be able to get the required GCB of the coal. And second thing is that you will be able to optimize the sourcing of the coal. Then you can able to optimize the logistic, train transport and all. So the main aim is to have a required GCB of the coal and to get the proper load condition. And since your bunker is very, very big in the most of the power plant where you are having a high capacity, so you will be able to know that by what time, which layer is having what GCB of the coal in the coal bunker. So the technology is, of course, I can say we use the AI and ML model. Uh, I will tell you that there, yes, just a moment. Uh, I will show you one. Yes. So for that, of course, we require the sensor in your stacker reclaimer. We must be able to know that where is the position of the stacker reclaimer right now. And second thing, we must have a GPS signal from the position of the stacker reclaimer we want, and we want also the position of the uh, intruders that is in the basically inside the which is in line in the bunker, and this will help the way generally you pile the coal in your own way. You pile the GCB one, let us suppose one of the rack has come, then you pile from the stacker reclaimer, you pile at one place. Or let us suppose your second train has come, you will know from your experience this is the best coal, so you put it directly to the bunker. So the way you work, but here you will have to pile the way the software will tell you. Of course, it will take the data of all the logistics and all, and it will tell you how to pile. Generally, I will show you. Just a moment. So here you can see that if this is the way the piling should be done. So that the different GCV of the coal will be piled like this. It's not that the way you pile, it will be piled like this, and you must be able to know that how much where you are having the coal of which GCB, and you are having the bench like upper and lower bench, and as per the requirement, it will tell you that yes, these are the bench which is having different GCB of the coal, and accordingly you will be able to send it to the bunker. So of course it requires some more time, and we
आप
are.
लोगों के पास नहीं है invitation?
Hmm? हाँ,
तो मुझे बोला था उसने
just a moment.
दिमाग में
Vedika, please mute yourself.
ऐसे पापा को मत बोलो.
So just I wanted to show you that yes, right now we are working on this coal selection matrix, and yes, of course the main aim is to provide the right GCB. You must be able to know that in which bench you are having which GCB of the coal, and whenever you require the required GCB of the coal, you must be able to do. And the main advantage of this one is this coal selection matrix where we are using this AI ML technology is this one that you must have a high boiler efficiency, and then you must have reduced lagging and clogging, unburned will be less, SOx emission control, FGD problem, low maintenance cost and all. So this we are implementing in one of the Mahagenco plant. So once it will be implemented, then I hope then which I will be able to explain you some more advantage of this. But of course, it requires the radio signal on the stacker reclaimer. That is one of the things, and that is little bit costly instrument also. But anyway, that's the thing. So if you have any question or something, I just give you my mobile number.
Sir, do you have any solution which will be useful for transmission utility?
Transmission utility, I think Vedika can give you a right result. Just a moment.
Yeah, actually we have digital twins for transmission and distribution, but we have not developed any AI tool for transmission utility till now. But of course, in the market, other than STIAG, there are available. for grid optimization and all. So for load forecasting, RE generation forecasting, these are also available. Yeah, but
And
STIAG has not
anything
developed.
regarding predictive maintenance or fault analysis kind of thing?
For transmission sector?
Yeah, transmission utility.
Yeah,
Because
no.
see, grid management and all will come as a part of SLDC, load dispatch center.
Yeah.
So we require we have a lot of inventories regarding CT, PT, and breaker. So there are a lot of fault occurs, and we have a abundance amount of predictive maintenance scheduled. So if we can optimize in that way, that will be more useful for us.
Yeah, actually, like Mr. Praveen Ambasta has shown you, we have developed predictive maintenance for coal, gas-based plants, combined cycle plants and all, but not for electrical modules right now for the transmission sector. But the same principles can be applied. We have not done it yet for transformers or transmission lines and all. So this we have not developed, but in the market they are available.
Okay, thank you.
One of the question is, can coal matrix model can be developed especially for coal mine? Actually, for coal mines also, yes, it can be done. But right now we are using it for this our coal yard in the power plant. No, it is fully developed. It is not under development. It is fully developed, and we are implementing this one. Can any model develop to predict scale thickness or corrosion measurement of condenser tube? Uh, Actually, we require the data. So, of course, we can predict that, yes, scaling is one of the reason for the fault, but how much is the scale thickness? That is definitely will be challenge. But yes, if we shall model this, of course, when there will be scaling will be there, then definitely DP will be high, the vacuum will be poor, and then we can check the CW flow. All these things, all these data we shall take into account, and then we can model, and then we can come to some conclusion that what is the reason for the bad vacuum. Scale thickness is second step. So if you have any more question, then otherwise you can contact me. Or you can contact Vedika Agarwal, Dr. Vedika Agarwal.
For the measurement of GCV online measurement, do you have any particular instrument make and
Actually, sir, we are having the digital twin that I have shown you. In the digital twin also, we have developed the one of the module that is to calculate the GCB of the coal, because for calculating the GCB of the coal, one thing is that we require the coal flow. You must have a coal flow measurement. You must have the gravimetric feeder.
No, not that. I'm saying actual GCV measurement, because once we take the coal sample and give
No,
it to the
sir.
chemist, it
Actually,
takes
for
time.
not, we calculate thermodynamically. From AI-based tool, we calculate from our AI-based tool, from our neural model, we calculate the GCB of the coal, and that is very, very correct. Correct calculation of GCB of the coal. Any hardware or anything that will not work. If you will put also online GCB of the coal, it will come in 2 to 3 crore, and it will not work. It will be worn out in maximum 2 to 3 years. Maximum it will work for 2 years. So it is better to have a digital twin type of tool, so that you will be able to know the GCB of the coal approximately. Approximately is very close. Not, I can say the difference will be 300 kilocalorie. No, it will be approximately less than 100 kilocalorie. That we have, honestly, we have we have found also, we tried with some of the NTPC power plant, and our result was less than 100 kilocalorie.